Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In our last lesson, we talked about friction and we talked about the types of frictions, angles of frictions, and we look at some examples under friction. But in today's lesson, we'll be looking at more examples on friction. But before we look at the examples, let's refresh back our memory on what we did on friction in an inclined plane. So let's say we have an inclined plane and we have the horizontal floor of the inclined plane. And let's say we have a wall. So let's say we have a block sliding down the plane. So this is the block. So the block is sliding down the plane with a motion. So this will be our motion. And here we have our frictional force that is opposing the motion. So this is the motion of the block sliding down an inclined plane. And here we have the angle, which is the theta that the inclined plane is making with the horizontal floor. So this is the horizontal ground. So now that we have the motion of the inclined plane and we have the frictional force acting, which is opposing the motion, we can have our normal reaction, which is our R, that is acting perpendicular to the plane. So this is our normal reaction. And here we have our weight, which is acting down the plane. So the weight is acting parallel to the plane, but the normal reaction is acting perpendicular to the surface of the inclined plane. So this is our normal reaction and this is our weight. So recall from what we said in our last lesson. We said the normal reaction, which is R, is given as the mg cos theta. So in this case, how do we get our mg cos theta? Remember from what we have, the SOHCAHTOA. So let me just write that here. So we have the SOHCAHTOA. So let's say this is our hypotenuse and this is our opposite, and we have our adjacent. So our normal reaction, the normal reaction is acting like an hypotenuse to the plane. So that is how we get our cos, which is the adjacent over hypotenuse. So this is the adjacent and this is our normal reaction. And this is the angle that the normal reaction is making with the horizontal floor. And that is how we get our R equals to mg cos theta. Remember that we said our R is always the same as the mg on friction on horizontal surface. So in this case, if our R is equal to mg cos theta, our frictional force, which is the friction of the plane of the block sliding down the plane, so our force of the block sliding down the plane, so the force of this block that is sliding down the plane will be given as F equals to the mg sine theta. So this is the formula for the block sliding down an inclined plane. So let's call this our equation 1. And this our equation 2. So these are the part of the formula that we'll be using to calculate the friction of force of an inclined plane. So let's look at other formulas that we have. Now that we have gotten the formula for our normal reaction, which is given as mg cos theta, and we have gotten our formula for the force of the block sliding down the plane, which is given as mg sin theta. So this is our force. This is just the force of the block sliding down the plane. So let's look for the formula of our frictional force. So to get our frictional force, remember that we said that the coefficient, so let me just write the frictional force here. Remember that we said the coefficient of static friction, which is given as mu equals to the frictional force over normal reaction. So in this case, we have gotten our normal reaction to be mg cos theta. So we can substitute that for our normal reaction in the coefficient of static friction. So the coefficient of static friction will be given as the frictional force over our normal reaction. And in this equation 1, our normal reaction is given as mg cos theta. So we can put that here. So we have our mg cos theta. So in this case, we can make our frictional force the subject of the formula. So we have our frictional force to be equal to, so when we cross multiply, this will multiply this moon. So we have our frictional force to be equal to the moon multiplied by the mg cos theta. So this is the formula for our frictional force. So our frictional force will be given as moon dot mg cos theta. This dot is still the same thing as multiplication. So we have this as our equation 3. So this is the formula for frictional force of an inclined plane. Now we'll be looking at the coefficient of static friction. So we have the coefficient of static friction. So looking at the formula for coefficient of static friction, we have our moon to be equal to the frictional force over normal reaction. So in this case, coefficient of static friction of an inclined plane can be given as the moon to be equal to, what is our force? So remember our force here is mg sin theta divided by our normal reaction. What is our normal reaction in this case? Our normal reaction is mg cos theta. So we have our mg cos theta. So this is given as the formula for coefficient of static friction of an inclined plane. So we can call this our equation 4. So if we can solve this formula, you can see the mg can cancel mg. So we have our coefficient of static friction to be equal to the sine theta over cos theta. So this is another formula for coefficient of static friction, because if mg cancel mg, you have your sine theta over cos theta. So you can call this your equation 5. And lastly, looking at the trigonometric relationship, when you have sine theta over cos theta, you have your coefficient of static friction, which is moon, to be equal to tan theta. So you can call this your equation 6. So these are formulas for coefficient of static friction. So the first formula is U equals to mg sin theta over mg cos theta. And the second formula is moon equals to sin theta over cos theta. So this sin theta over cos theta, if you cancel this mg and mg, you have your sin theta over cos theta. And that is how we get this formula for equation 5. And lastly, from trigonometric identity, if you have sin theta over cos theta, you have tan theta. And this is a proof of trigonometry, and that is how we get our last equation, which is the equation 6. So this is the formula for coefficient of static friction. And lastly, on the formula for frictional force of an inclined plane, we have the vertical component and the horizontal component. So for the vertical component, we have our frictional force to be equal to the force sine theta, and this is given as our vertical component. This is standing as the force, and this is the frictional force. And for the horizontal component, we have our frictional force to be equal to the F cos theta, and this is given as our formula for the horizontal component. So this is standing as our force. So we can call this our equation 7, and we can call this our equation 8. So these are formulas to know if you are solving any question under friction of an inclined plane. So knowing all this formula, you'll be able to tackle any question under friction of an inclined plane. So now that we have studied all this formula, we can then consider looking at some examples under friction of an inclined plane. So let's look at some examples under friction of an inclined plane. Our first examples, as displayed on the screen, says that A load is pulled at a uniform speed along a horizontal floor by a rope at 45 degrees to the floor. If the force of the rope is 1500 Newton, what is the frictional force on the load? So looking at this question, we are given the parameters. So our given parameters, the first parameters that we are given is the theta, which is the angle, to be equal to 45 degrees. And we were also given the force, which is equal to the 1500 Newton. So these are the two parameters that we are given in this question. And the question is asking that what is the frictional force on the load? So they are asking the frictional force, which is Fr, to be equal to unknown. So looking at this question, which of this formula do you think that we can apply to this kind of question? So now, looking at all this formula on the board, you can see the formula that we can apply to this question is the horizontal component, because they are asking that what is the frictional force on the load, and they are talking about an horizontal floor in this question. So we'll be using the horizontal component, and the formula for the horizontal component is given as frictional force, which is Fr, to be equal to the F cos theta. Note that they are talking about an horizontal floor in this question, and that is how we are using the horizontal component to this question. So our formula for the horizontal component is given as frictional force equal to the F cos theta. So in this case, I told you that our F is force, so we have our frictional force to be equal to the force, which is 1500, multiplied by the cos angle of the theta given. So the theta, the angle that we are given is 45 degrees. And that is how we have our formula of this kind of question. So when we resolve this, we have our frictional force to be equal to the 1500 multiplied by, and when you press the cos 45 in your calculator, you have your cos 45 to be 0.7071, and when you multiply this, you have our frictional force to be equal to 1060.65 Newton. And this is given as our final answer to questions of this type. Another examples as displayed on the screen says that a metal block of mass 5 kg lies on a rough horizontal platform. If a horizontal force of 8 Newton applied to the block through its center mass just like the block on the platform, then the coefficient of limiting friction between the block and the platform is. So in this kind of question, we are given the mass, which is the m, to be equal to 5 kilogram, and we are given the force, which is the frictional force on the horizontal floor, to be equal to 8 Newton. And they are asking us to calculate the coefficient of static friction, which is the mole. So the coefficient of static friction is unknown. So in this kind of question, what formula do you think we can apply to this kind of question? So remember that we said the coefficient of static friction, which is mole, is equal to the frictional force over normal reaction. And in this case, we are only given the frictional force, which is 8 Newton. We are not given the normal reaction. So remember in our last lesson, we said to get the normal reaction, we said the normal reaction is also equal to the weight, which is also equal to mass times gravity. So in this case, we can say our normal reaction, which is R, to be equal to, what is our mass? 5 multiplied by the gravity, which is 10. So our normal reaction will be given as 50. So in this case, now that we have gotten our normal reaction, we can see our moon, which is the coefficient of static friction, to be equal to our frictional force, which is 8 Newton, divided by our normal reaction, which is 50. So our coefficient of static friction will be given as moon equal to 0.16. So the coefficient of static friction doesn't have any units, and this is given as our final answer to questions of this type. So our moon is equal to 0.16, and that is our final answer to questions of this type. Another example we have, as shown on the screen, says that a body of mass 6 kg rests on an inclined plane. The normal reaction is R and the limiting frictional force is F, as shown in the diagram. If the force F is 30 Newton and the G is 10 meters per second, then the angle of inclination of the plane is. So in this kind of question, we are given the mass, which is equal to M, to be 6 kg, and we are given the frictional force, which is F, to be 30 Newton. And lastly, we were given the G to be 10 meters per second squared. So they are asking us for the angle theta to this question. So how do we get the angle theta? Looking at all this formula that we have on the board, what formula do you think would be suitable for this kind of question? So looking at the formula, we can use the formula in our equation 2, which is the frictional force of the block sliding down the plane. So for this formula, we have our frictional force to be equal to F equals to, so looking at this equation 3, we have our F to be equal to mg sine theta. So to this kind of question, what is our F? Our F is given as 30 Newton, which is the frictional force. So we have the 30 Newton, okay. We have the 30 Newton to be equal to, what is our mass? So our mass is 6 in this case, multiplied by, what is our gravity? Our gravity is 10, multiplied by our sine angle that we are looking for. So we are looking for sine theta in this case. So when we solve this, we have our 30 to be equal to 60 multiplied by sine theta. And we can make sine theta the subject of the formula. So making sine theta the subject of the formula, we have sine theta to be equal to 30 divided by 60. And when we do this, we have our sine theta to be equal to 0.5. So to get this theta, we have to make the sine inverse of whatever we are having on this other side of the opposite side. So we have our theta to be equal to the sine inverse of 0.5. So when you do the sine inverse of 0.5, our theta will be equal to 30 degrees. And this is our final answer to questions of this type. Another example, as displayed on the screen, says that the coefficient of static friction between a 40 kg crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base inclined at angle 45 degrees to the horizontal, taking G to be 10 meters per second square. So in this kind of question, they are asking us to calculate the minimum force to keep it stationary or balanced. So in our given parameters, we are given the mass to be equal to 40 kg, and we're given the coefficient of static friction, which is mole, to be equal to 0.25. And we're also given the angle, which is the theta, to be equal to 45 degrees. And lastly, we're given the G to be equal to 10. So they're asking us to calculate the minimum force to keep it stationary or keep it balanced. So in this kind of question, when they're asking you to calculate the minimum force to keep a particular body stationary or balanced, we'll be using the formula for our F net. So they're asking us to calculate the F net. So this one is the total force or the net force of the inclined plane. So the formula for the net force is given as F net is equal to the force that is required for the object to slide down the plane minus the frictional force. So this is the force required to keep the object sliding and the frictional force. So this is our frictional force. And this is just the force to keep it sliding. So this way, the frictional force will be subtracted from the force to keep the object sliding down the inclined plane. So we know that our F net is equal to, what is our force to keep it sliding? Our force to keep it sliding is given as mg sine theta. So we have our mg sine theta minus, what is our frictional force? Remember, our frictional force is given as umg cos theta. So we have our umg, u dot mg cos theta. And this is given as our formula for the net force. So if we calculate the force that are required for the body to slide down the plane, we have our F to be equal to, what is our M? Our mass is 40 multiplied by, what is our gravity, which is 10, multiplied by the sine angle of what we are given, which is sine 45 degrees. So in this case, we have our F to be equal to 400 multiplied by sine 45, which is 0.7071. So our F will be given as 282.84 Newton. So now that we have gotten our small f, We can then get our big F, which is the frictional force, which is given as umg cos theta. So our frictional force, which is the big F, will be given as umg cos theta. So this is given as, what is our u? Our u is given as 0.25 multiplied by our mg, which is 40 times 10, and we multiply this by the cos theta that we were given, which is cos 45 degrees. And when we multiply this, we have our frictional force to be given as 0.25 multiplied by 400 multiplied by 0.7071, and our frictional force, which is F, will be given as 70.71 Newton. So now that we have gotten our small force, which is the force that is required for the block to keep sliding the plane, and we have also getting our frictional force, which is the frictional force of the body of the plane, we can then proceed to calculate our F net, which is given as the force required for the block to keep sliding the plane minus the frictional force. So the force required for the block to keep sliding the plane is given as our 282.84. So we have our F net to be equal to 282.84 subtracted by our frictional force, which is 70.71. So our F net will be given as 212.13 Newton. And this is given as our final answer to questions of this type. Another example that we have says that a body of mass 10 kg rests on a rough inclined plane whose angle of tilt Q is variable. They gradually increase until the body starts to slide down the plane at angle 30 degrees. The coefficient of limiting friction between the body and the plane is. So in this kind of question, we are given the mass, which is m, to be equal to 10 kilogram, and we are given the angle, which is theta, to be equal to 30 degrees. And lastly, we are given the gravity, which is equal to 10. So they ask us to calculate the coefficient of static friction, which is known to be equal to unknown. So in this kind of question, there's a two way that we can use to solve this question. The easiest way is just by saying the coefficient of friction, which is known, is equal to tan theta. So you can see the formula here, the moon, in our equation 6. You can see the formula for coefficient of static friction is equal to tan theta. So you can say that the coefficient of static friction, which is moon, is equal to tan 30 degrees. And when you press this in your calculator, you have the coefficient of static friction to be equal to 0.58. And this is our final answer to questions of this type. And another way you can use to solve it is by using the formula that we have in our equation 4, which is given as mg sin theta over mg cos theta. So if you are using this kind of formula, we have our coefficient of static friction to be equal to the mg sin theta, which is 10 times 10 multiplied by sin theta. So we have our 10 times 10 multiplied by sin 30 degrees divided by our mg cos theta, which is still 10 times 10 multiplied by cos 30 degrees. So in this kind of question, you can cancel this and cancel this. So we have our coefficient of static friction to be equal to sin 30 divided by cos 30. So you can see we are still coming back to the equation that we have in this equation 5, which is sin theta over cos theta. So here we are having sin 30 over cos 30. So our coefficient of static friction will be given as, what is sin 30? Sin 30 is 0.5 divided by 0.8660. And when you calculate this, you have your coefficient of static friction to be equal to 0.58. And you can see we arrive at the same answer to this question. So you can use either any of these formula to calculate the coefficient of static friction. So this is our final answer to questions of this type. And the last question we have says that calculate the magnitude of the force required to just move a 20 kg object along a horizontal surface if the coefficient of friction is 0.2. So in this kind of question, we are giving the mass as our parameter to be equal to 20 kg, and we are giving the coefficient of static friction, which is our mole, to be equal to 0.2, and they are asking us to calculate the frictional force, the magnitude of the frictional force in this kind of question. So we have our frictional force, So this is what they are asking us to calculate. So in this kind of question, our coefficient of static friction is given as the force, which is the frictional force over normal reaction. So in this case, our frictional force is unknown, but our coefficient of static friction, which is mu, is 0.2, and our normal reaction is also unknown. So to get our normal reaction, remember I said the W is also equal to the normal reaction, which is also equal to M multiplied by the G, which is the mass times gravity. So in this case, we are given the mass, which is 20 newtons. So our R will be equal to our mass, which is 20, multiplied by the gravity, which is 10. Our R will be equal to 200 Newton. So in this case, we can then calculate our frictional force by saying the coefficient of static friction, which is 0.2, is equal to our frictional force, which is unknown, divided by the normal reaction, which is 200 Newton. So when we cross multiply, we have our frictional force to be equal to the 0.2 multiplied by the 200 Newton. So our frictional force will be equal to 40 Newton. And this is our final answer to questions of this type. And that will be all about frictional force, examples on friction. Attempt this question displayed on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And if you found this helpful, don't forget to subscribe to Tech and EduSpark Hub. Turn on the notification bell so you won't miss any lesson updates. And until next time, keep learning, keep coding, and I will see you in the next one.